Hello Ace, this is RetroTK2 and today we're taking a look at enums in C#. If this is your first C# video, might I suggest watching the series from the start. The card to the playlist should be on your screen now. And if you haven't already, why not download the channel files that accompany this video. Card should be on your screen once again. So let's get started. Well, what is an enum? According to the Microsoft Docs, the enum keyword is used to declare an enumeration, a distinct type that consists of a set of named constants called the enumerator list. Enum can also be nested within a class or struct. By default, the first enumerator has the value 0, and the value of each successive enumerator is increased by 1. Enumerators can use initializers to override the default values. So if you set the first element to 0, the subsequent elements will increase in the sequence 2, 3, 4, and so on. Including a constant that has the value of 0 is recommended. The default underlying type of enumeration elements is int. To declare an enum of another integral type, such as byte, use a colon after the identifier followed by the type. The approved types for an enum are byte, sbyte, short, ushort, int, uint, long, or ulong. Most of these data types we haven't come across yet, so we'll just be focusing on the standard int. The default value of an enum e is the value produced by the expression brackets e, close brackets, 0. I would say this is why including an element with the value of 0 is recommended, since our enum will initialize with 0 as the default value. An enumerator cannot contain white space in its name. Though I would say we've come to expect that with all types in C# by now. The underlying type specifies how much storage is allocated for each enumerator. However, an explicit cast is necessary to convert from enum type to an integral type. The explicit cast mentioned here is to do with something called typecasting. I really don't want to spend too long on typecasting in this video, since it's a whole entirely different beast in its own right. We will be covering it a little later in the series, so be sure to subscribe for that. Wonderful! You can also apply system flag attributes to an enumeration. This is to do with bitwise operations, but unfortunately they won't be covered in this series. But we will get onto them at some point, I promise. Right, a ton of extremely good information there, though it might be a bit overwhelming at this point. Let's go through these slowly. Open up Unity and create a basic C# script. As always, make sure you give your script a different name than any other class in your project. As with the last video, I'll be using the Unity Spice plugin for our logouts. If you'd like to get it for yourself for free, please follow the card on your screen now, or follow the link in the description. Declaring an enum is somewhat similar to a class. You first declare your access modifiers, and then add the enum keyword. Then you give your enum a name. Here I'll be creating an enum of days in a week, so I'll just call it days. And open then close your curly braces. Now our declaration switches a bit to resemble that of an array, since I can add in all my days and separate them with a comma. And that's our enum declared, nothing too crazy there. The doc said that our enum's default type is an int, but we can change that by placing a colon after our enum's name and declaring a type. I'm perfectly happy with the int, so I shall leave it at that. Okay, now we'll create an instance of our enum. Here I'm declaring a variable called day. To access an element in our enum, we first type out the enum's name, so days in this case, Now if I add a dot, you'll see all the elements in our enum list. Simply choose the one you want and close the whole thing off with a semicolon. And that's pretty much it, easy peasy. So now we can log out our element. Save, head back into Unity. Drag our tutorial 20 script onto any game object in the scene, and run the game. And hey, Friday is logged. But what if you're looking for the numerical value of the enum? Well, that's where our typecasting comes in, If you know that the enum is represented by ints, you can cast your enum variable to the type int. Here we're changing our enum's variable type to an int. We can also cast an int to our enum's type as well, and if the value is represented in our list, it should log out as a string representation of one of our days. Save, head back into Unity, and rerun. And 4 is logged since it represents the element Friday. And Thursday is logged since it is represented by the int value 3. Again, yes, I hate having to bring up the topic of typecasting so early, because it's probably difficult to see exactly how this works. But we'll go into it with a lot more detail when we cover the topic later on. For now, simply know that we can swap between enum representations using this method. Now, whenever you do this, Ace, you're making a potentially dangerous assumption. You're assuming that the values that your enum elements represent will never change. But what if I was to change our starting value to 1? What do we expect the output to be, Ace? Save, head back into Unity, and rerun the game. And now we get a very different set of values logged. Wednesday is logged since it is now represented by the int 3, and Friday is now 5. Assuming that the int values of your enum will be the same forever can be fatal, Ace, so please do bear that in mind. Now we've already seen that our elements increase by 1 each time if they aren't supplied a value. But if I assign a completely different value to one of the elements, say 90 in this case, the following elements will still increase by 1, but they'll start from 90. If I log out all the elements with the respective int values, you'll see we get 1, 2, 3, as we have seen before. Then we get our newly assigned 90 value. And hey, we start a new sequence with 91, 92, and 93. Hopefully this is fairly obvious, Ace. You can also loop through all the values in your enum, Ace. Declare a standard for each loop. Now to get the values of the enum list, we need to call the static method getValues on the enum class. I hate having to talk about static methods here, Ace, but even worse, I need to talk about the type object as well. More importantly, the typeOf method. I really don't want to go into detail with this topic, Ace, since I'll be doing a video on it in the not too distant future. For now, we can say that the typeOf method gets us the type as an object that we can pass as a parameter to our methods. Here we're passing it to the getValues method to return an array of all the enum values. And that's as far as we're going to take that explanation for now, Ace. We can also check against the value of our enums using an if statement. Declare your if and check to see if your variable is equal to a particular element. Or you could even check to see if it's not equal to a particular enumeration. Now that's all well and good, Ace, but what's the point in all this? Why would you ever want to use an enum? Well, enums are great for lightweight state checks, Ace, and are also great when the value of the constants isn't really that important. They can also be really good for representing numbers that are never going to change, though these can also be represented by constants in a static class. Using them with bitwise flags can be really useful too, yes, but we'll save all that for a future series. This has been a really basic look at enums in C#. I'm really sorry that I had to dip into several uncovered topics here, yes, but they're just too important to breeze over, unfortunately. And that's it. Rate, comment and subscribe, yes. Be sure to use enums in your code. You can email me at retrotk2@gmail.com with any questions you have about enums. Thank you for watching this, and I'll see you in the next video.